This is MATHguide.com, and my name is Mark Karadimos. In this video, we're going to talk about vector dot products. In our first section, we're going to talk about the definition of a dot product. Then we're going to go into some examples. We're going to talk about the meaning of a dot product. And then we're going to talk about how we could test for orthogonality. All right, let's get started. Let's talk about the definition of what a dot product is. In order to understand this definition, you first have to understand a little something about vectors. Vectors in a plane have two components. They have a horizontal component and a vertical component. So that's what these little subscripts mean. So for our first vector u, you could see that it has two parts. It has the horizontal component and it has the vertical component. And I have another vector v with the same thing. It has a horizontal and it has a vertical component. Now, according to this definition, the way we calculate a dot product is fairly simple. You take the product of the horizontal components, you take the product of the vertical components, and then you find the sum of those products. Yep, it's really not that complicated, especially when you're given the vectors in horizontal and vertical form. Okay, so in our next section, we're going to show you how to use it. Here we go. So let's calculate the dot product with these two examples. So for example 1, we're going to find the dot product of u and v. So I'm going to multiply the horizontal components, 5 and 3. I'm going to multiply the vertical components, -2 and 7. And of course, I'm going to find the sum of those products. So here I'm going to get 15. Here I'm going to get -14. So that has a dot product that's equal to 1. Okay, over here we're going to take u dot v. Again, we're going to take -9 and 2. Those are the horizontal products. Then we're going to find the sum of the products of, let's see, now we're going to find the product of the vertical. So that would be -1 and -3. So that would be -18. That would be 3. So that would be a -15. And there you go. I've just calculated the dot product twice. So let's talk about the meaning of what a dot product is. Qualitatively speaking, when you take the dot product of two vectors, it's really about how much the two vectors have in common. And this is more properly understood by taking a look at the dot product's second definition. Yeah, there's a second definition of dot product. So the alternate definition is that if I want to find the dot product of two vectors, I take the magnitude of each vector and multiply it by the cosine of the angle between the two vectors. And in doing that, you could find the dot product. And it's equal to the same quantity we would get had we used the other definition for dot product that we started with a few moments back. Okay, so I wanted you to understand that there is a qualitative way of looking at it, and it's also about how much the two vectors have in common. In other words, how closely are the two vectors aligned or headed in the same direction? Two vectors are said to be orthogonal when they have a dot product equal to 0. So of course I have this in mathematical ease. If you see down below, given two vectors, if u dot v is equal to 0, then u and v are called orthogonal vectors. So let's take a look at an example of how this could happen. Let's say we have vectors 3 and 5. Let's say we've got vector 10 and -6. All right, let's say I find the dot product of these two vectors. Okay, so I would take the horizontal part times the horizontal part. I would take the vertical part times the vertical part. Of course, find the sum of these two products. So what do I get? I get 30. I get negative 30. Now I know, since my dot product is equal to 0, that these two vectors are indeed orthogonal. Now orthogonal is just a fancy word. It means they're perpendicular. So if you were to put these two vectors next to each other so that their tails meet, right? So you have one tail on top of the other tail, you would see that the angle between the two vectors would be 90 degrees. All right, this has been MATHguide.com. You just saw a video about dot products and vectors. Make sure you go back to MATHguide.com, check out our instructional videos, our interactive quizzes, and text-based lessons. Take care.